So now we'll discuss how to design the digital filter by using impulse invariant method. So so these are the steps. What is that? First step is, first we have to design the analog filter. Okay, whatever it is, Butterworth or Chebyshev, whatever filter. First we have to design analog filter, HA of S. HA of S, just now we have discussed now how to design HA of S. Okay. After that, what is that? Next step is select the sampling rate of digital filter. So usually t value is given in the problem itself. Okay. If t value is not given, take t is equal to 1 second per sample. Okay. Then what do you have to do? The third step, this is very important step. We have to write, so we have to write the transfer function in what is that? Partial fraction form. Okay, like a single pole form only you have to write it. Okay, so if you are getting complex poles also, you have to write single poles only, you should not write two poles. Okay, so write the transfer function as sum of single pole filters like this. Okay, partial fraction form if you have to write. Then what you have to do, ck by s minus pk will be having, no, so this should be directly converted to ck by, so s minus pk, s minus pk should be written as 1 minus e power pkt z inverse. Okay, t value is given, no, already. T is whatever given in the problem. Okay, e power pk means this is the value whatever pole you have, e power pkt z power minus 1. So if you are getting ck by s plus pk, how you have to write? S minus of minus pk. So here minus pk will be having, here also will be having minus pk. Okay, so this is for low sampling rates. If it is for high sampling rates, what you have to do? Here we'll be having t ck by 1 minus e power pkt z inverse. So you understood the denominator. What is the, in the analog filter, in the denominator we have s minus pk, no, s minus pk should be directly replaced with 1 minus e power pkt z inverse. Okay, and if it is for high sampling rate, so in the denominator also you'll be having tck divided by 1 minus e power pkt z inverse. This is the steps we have to follow. Okay, now we see the problems here. Okay, see here, h of s is given, analog filter is given directly, and t value is also given, t is equal to 1 second. Now we have to design the digital filter using impulse invariant method. So what we have discussed, the first step. So after finding analog filter, what you have to do? Write the filter in partial fraction form, where each term should have only one pole. Okay, so write HA of s is a by s plus 1 plus b by s plus 2. Now find out a and b. Okay, just now I told, no, here you should have s minus pk. S, here you have s plus 1, no, so we write it as s minus of minus 1 minus 2 by s minus of minus 2. So just now we told that ck by, see here ma, ck by e power s minus pk should be replaced with what? Ck by 1 minus e power pkt z inverse. Okay, so ck numerator will be same. Numerator will be same. The denominator should be replaced with what? 1 minus e power pk. What is pk value? Minus 1 t z inverse. Okay, minus 2, numerator will be same, minus 2 divided by, denominator should be replaced with 1 minus e power pk is what? Minus 2, no, here 1 minus e power minus 2 t z inverse. Okay, so t value is given as 1 second. T value is what? In the problem it is given as 1 second. We substitute t is equal to 1, and finally we simplify this. Okay, now there is one more procedure here to find out the digital filter transfer function using impulse invariant method that we discuss here. What is that? Here h of s given, h of s is equal to s square plus root tt root 2s plus 1. No, what is that? We have to find out. First we have to find out h of t. What is h of t, ma? H of t is nothing but impulse response. After finding h of t, find out h of nt. Okay, That is that we are sampling h of t with t seconds. So continuous will be converted to discrete. H of nt will be finding. After finding h of nt, find out z transform. So you get h of z. That is the procedure. That procedure also can be used. So for this problem, we are using that procedure. What is that? H of s is given. Find out h of t. What is h of s? Is the Laplace transform, no? So we are taking Laplace inverse of h of s. Okay. So if you find out Laplace inverse, we get h of t is equal to root 2 e power minus t by root 2 sine t by root 2. Okay. So it is in the form, see here, it is some constant divided by s plus a square plus b square. Okay. So it is in that form. Okay, so it is b by s plus a square plus b square. So it is e power, so b here numerator you have, so it is in the sign form. Okay, so that relations, if you just go through that relations once again. Okay, after finding h of t, what is that you have to do? Find out h of nt, sample it. Wherever t you have, replace with n capital T. Okay, t is capital T is equal to 1 second. Okay, so after finding h of nt, apply z transform so that you get h of z. Okay, most of the cases you get this problems only, the first method of problem whatever we have discussed here, only that problem will get. So if this type of problems are also given, you no need to bother. Find out h of t, substitute t with nt, so find out h of nt and apply z transform. Okay, and see here, design third order Butterworth filter using impulse invariant technique. Assume t is equal to 1 second. Okay, n is equal to 3. Okay, third order Butterworth filter already we have solved. So we are directly writing h of s is equal to, this is the third order Butterworth filter with the cutoff frequency is equal to 1 radian per second. What I told you, we should write it in partial fraction form where each element, each term should have only one pole. Okay, so like that we are writing. Find out abc. After finding abc, we substitute abc, write h of s. We got h of s is like this. Okay, now what is h of z? So wherever you have ck by s minus pk should be replaced with what? Ck by 1 minus e power pkt z inverse, yes or no? So here what is pk minus 1, no? So it is 1 by 1 minus e power minus 1 z inverse. Okay, plus, and here you see this is your pk, so the same term will be substituting here. Okay, whereas here in the third term this is our pk, that is minus 0.5 plus j 0.6866. Okay, so that same term will be substituted where t value is 1. T value is 1. T is we have substituted as 1. Then finally we are simplifying this. Okay. So here we see that s plus a by s plus a square plus b square. So what is this? Its inverse Laplace transform is e power minus at cos bt. S plus a by s plus a square plus b square. Inverse Laplace transform is what? E power minus at cos bt. Okay. And b by, see here, b by s plus a square plus b square is nothing but e power minus at sine bt. So here it is s plus a by s plus a square plus b square is e power minus at cos bt, no? Okay. Now what is that we are doing? T is equal to nt. So you got this. Okay. Then we are applying z transform to this. Okay. If you apply z transform, we get h of z. Okay. So this the third problem. Whatever we have discussed here, sir, this is the fourth problem. No, is similar to the first problem here. Fourth problem is similar to the second problem here. Okay. Any doubts here? Similarly, you see here analog filter h of s is given. It is 10 by s square plus 7s plus 10. T value is given as 0.2 seconds. Okay. What is our first step? Write it in partial fraction form where each term will have only one pole. Okay. After writing in partial fraction form, find out a and b. Okay. So what is that we have to do? Since it is, see here, t value is very small, means high sampling rate. If t is small, the sampling rate is high sampling rate. That is why numerator should also multiplied with t. Okay, so t, we are multiplying numerator with t here. see s plus 5, that is s minus of minus 5 will be replaced with 1 minus e power minus 5t z inverse. Okay, here also s minus pk, s minus pk will be replaced with 1 minus e power pkt z inverse. Here pk is minus 2, no, that is why we are substituting minus 2. Okay, so similarly we have to simplify this. If t value is small, means sampling rate is high. If sampling rate is high, you see this step, all of you, if sampling rate is high, what do you have to do? We have to multiply numerator is also with t here. Okay, so that is why here t is 0.2, means the sampling rate is high. That is why we are multiplying numerator with t. Okay, so this is the other problem. What you have to do, you have to write it in partial fraction form, where we will be getting 3 terms and each term should have only one pole. Then we are directly, since t is 1, you no need to multiply numerator with t. Okay, directly you can take ck by e power minus pkt e power 1 minus sorry, ck by 1 minus e power pkt z inverse. Okay, so that is the procedure we have to use to design digital filter using impulse invariant.